Welcome back. You should have page 55 ripped out of your workbook. Keep your journal out for a little while, and you're going to need your pencil and the two colors that were still left. What we're going to be doing is exploring a new concept with place values and decimals that have to do with metric measures of length. So I'm sure you have heard words like meter, decimeter, centimeter, millimeter. And those are just measurements that help us measure distance or length of something, okay? This is the metric system. A lot of places all over the world use the metric system. The United States does not actually. The United States uses something called customary units, but we are familiar with the metric system so that we can interact regularly and understand the countries and the places that do use this. So a meter, a decimeter, a centimeter, a millimeter. Okay, here's what I kind of like to remember. A millimeter is like the length of the tip of your pencil lead. So pretty dang tiny, right? A centimeter is like the length of maybe your fingernail from left to right. It's pretty interesting, right? A decimeter would be maybe like your pencil, right? Because it would be 10 of your fingers. 10 fingernail length. So it's probably about the length, a decimeter is probably about the length of a pencil. And then a meter is like a big long yardstick. It's really close to a yard. We have a meter stick actually hanging up in our classroom at the front of the board. So that is a meter stick. So it's about 10 pencils length, okay? So there's about 10 of these measurements in a fingernail. There's 10 fingernails in a pencil, and there's 10 pencils in a meter. That's because the metric system is all about base 10, using base 10 numbers. So the reason why we had to review all that really quickly, if you look at the bottom of page 55, take a look at this chart. It is really important that you're paying attention right now. So whatever it is that might be distracting you, try to take a deep breath and focus and really pay attention. Remember, we have the ones place value right here in red. And it's just showing you all the different ways we've learned it. 1 with a decimal after it. 1 over 1. That's a fraction, which just means 1. We've learned it maybe in money, $1. And now they're telling it to us in a measurement form. So we're adding one more layer of understanding. 1 meter. Okay? If I step to the left, remember, as I step to the left, I get 10 times larger. I multiply by 10. So that 1 changed to 10. Look, there's the decimal at the end of it. What did 1 times by 10 mean in a fraction? 10 over 1, which is just 10. What is money times 10? A dollar times 10? $10. So now they're teaching you that, well, a meter times 10 is called a decameter. A decameter. Okay? And just so you're aware, a decameter is 10 meters. It's pretty long. Let's keep going. Remember, as you step to the left from the blue box, you're going to get 10 times bigger again. So, as you can see, all of these change to 100, 100, 100. So, how many hectometers? So how many meters is 1 hectometer? 100. It takes 100 meters to get 1 hectometer. And then times that by 10. It takes 1,000 meters to get 1 kilometer or kilometer. Most people say kilometer. So you can tell that we're following the same pattern. 1, 10, 100, 1,000. So what do you think happens on this side of the decimal? Instead of it being 10, it's going to be 1/10. And instead of 100, it's going to be 1/100th of a meter. And this one's going to be 1,000th of a meter. And remember, those could be represented like this: 0.1, 0.01, 0.001. So I really wanted to draw your attention to this chart because we are going to be gluing it into our journal, and we're going to now be asked some questions about this. Remember, starting at the ones place, well, actually anywhere. If you start anywhere and you move to the left, you're multiplying by 10. If you move to the right, you're dividing by 10. So if I move to the left, starting here, and I move twice, I'm multiplying not just by 10, but I'd be multiplying by 10 again, which means technically to get from red to this green, I multiplied by 100. 10 to the second power, which is 100. All right, so let's answer the questions now on number 1 through 6. It says use your paper ruler, that's this right here, to answer each question, okay? How many decimeters, that's down here, decimeters. How many decimeters equal 1 meter? So if I'm going to step from here to there, I have to multiply by 10. So it takes 10 decimeters to get to a meter. Next question. How many millimeters equal 1 centimeter? Milli to centi. So here's milli, clear at the end, and I'm getting to centi going this way. One step that way means what? Times by 10. So it's 10. How many millimeters equal 1 decimeter? Here's milli, and here's deci. This time I'm going to use green. So I'm going once, twice. Milli to deci was not just 10, but it's 10 times 10, which is 100. That means there are 100 teeny tiny millimeters, tips of pencils, within the pencil. Because remember, this is our decimeter. Pretty interesting, huh? Okay, next. How many millimeters, again at the bottom here, equal 1 meter? Let's use purple this time. We're going clear from purple to red. Here we go. That's times 10 times 100, 1,000. There are 1,000 millimeters in a meter. Okay. What about centimeters to decimeter? Okay. Centi right here to deci. Let's just use our pencil. Centi to deci. That's only one step. To the left, times by 10. It's just 10. How many centimeters equal a meter? Centi. Let's use green this time. Centi's right here. Going to not just deci, but clear over to meter. I moved 2 times. So times 10 times 10, which is 10 times 10, 100. Counted those pretty well. We have already done number 7, just so you know, because we filled in these blanks down here. And we already did number 8 because we filled in the blanks as well. So we are technically done with page 55 already. See, it went pretty quickly. This is something important to know, that same thing as you move through place values, as you step left, you times by 10. And if you step left again, you would times by 10 again. If you move right, then you're dividing by 10. Okay, that is good to remember. We will be cutting that out and gluing it in just a little bit. But for right now, please turn the page to 56. Page 56, we're going to be doing a lot of practicing, and I think it's important that you pay attention. Make sure your name and number is at the top right corner of the screen. Okay, it says read each measurement below. Say the number of meters, decimeters, centimeters, and millimeters. So they do number 9 for you right here. So just draw an arrow up for number 9. They say that this number is 7 meters, because it's in the ones place, 2 decimeters, because it's in the deci place, 8 centimeters, and 4 millimeters. So let's look at this one. On number 10, this is meters, the ones place value. That one is meters. So what was to the left of the meters? Well, I know what it is, but if you're not sure, flip over your paper and use your chart. Here is the meters. What was to the left? Decameters. Okay, so let's practice saying this. 4 decameters, 5 meters. 1 decimeters, that's different, decimeters, 3 centimeters, and 2 millimeters. Let's do number 11. 2 decameters, say them with me, 9 meters. 1 decimeters, I always get confused on that one, it's this one straight up, and 6 centimeters. Number 12. Ooh. There's the decimal and the ones place right here at the end. So I have meters, decameters, and I need to go find out what that is. So let's go to here. I have meters, decameters, and hecto. Hecto is 100. So I say this. Ready? Here we go. I have 3 hectometers. Let's write hecto. I have, well, you don't say anything for 0. So 4 meters. I have 3 hectometers and 4 meters. That's all. Number 13, I have 1 decameter, 6 meters, and you don't need to say 0, 2 centimeters because it's in the hundredths place. Centi. Will you write centi, please? Centi. Okay, those were just quick practices. And now what we're doing on the rest of these are some story problems. So we get to use all of our journal steps that we just did about adding and subtracting decimals and making sure that we follow the steps that are as easy as 1, 2, 3. So, first step, stack them up. Make sure you line up place values correctly. Second, do what you're supposed to do. Fly and 0 the heroes if necessary. 3, circle your answer, look for labels and measurements, and put it in a complete sentence. Pretty easy. Number 14, you should leave out your green and purple to be able to highlight. Let's use purple. Tori had fabric that was 6.2 meters long. 6.2 meters, they've got a measurement. She used some, and now has 1.45 meters. How much did she use? Well, this is what she started with. We don't know what she used, but we know what she ended with. So we're going to be doing what? Subtracting. We're going to do step number 1, which is to stack it up. With subtraction, it doesn't matter which one you put on top. You're going to put the number that she began with, which is 6.2. Make sure you remember that it's meters when we get to the end, but stack it up. 6.2 minus 1.45. Which of these numbers, 1, 4, 5, is in the ones place? It's the 1. So it has to go right here underneath the ones place. Then there's the decimal, just like the button man. And then I have a 4 in the tenths, and they have a 5. We've got a 5 here in the hundredths. That means I'm going to use green, to fly and 0 the hero. See, I'm already on step number 2. And now I do normal subtraction. Here we go. 0 minus 5. 0 hundredths. Take away 5 hundredths. I can't do that. So I have to do the borrowing and regrouping that you're so familiar with. Now I can do 10 hundredths minus 5 hundredths. It's 5. And 1 minus 4 tenths. You can't do that. You have to borrow over here from the ones place value. Regroup. 11 minus 4, 7. Decimal, decimal, decimal. Do you know the button man, the button man, the button man? Do you know the button man? He lines the decimals up. So don't be crazy. Stack it all nicely. And 5 minus 1, so I'm in the ones place. 5 minus 1 is 4. That is my final answer, so I circle it. But now I need to put a label on it, which is meters, and put it in a complete sentence. How much did she use? She used 4.75, and make sure you label it, meters. I'm going to keep going to make it longer, of fabric. You could even use her name instead of she, right? Lots of ways for you to get better at that. Okay, let's try the next one. About Matt. Matt is competing in the long jump event. His first jump was 3.56 meters. Let's use green. That seems important. That's how you abbreviate meters. So far, the longest jump in the event is 4.02 meters. How much farther? Ooh, I know it's subtraction because of that phrase. How much farther than his first jump must Matt jump to be in first place? How much farther does he need to go? Okay. So he first went 3.56, and so far the longest is 4.02. So we want to do 4.02. Make sure you stack them up. Minus 3.56. Do you know the button man, right? He lines the decimals up, make sure all the place values are right. I don't need to zero the hero. They both ended in hundredths. So I just start on the right. 2 minus 6, can't do it. You go to borrow. You can't borrow from a 0. You have to go clear over to the ones place. Borrow. Make it a 10. Regroup. Make that one a 12. 12 minus 6 is 6. 9 minus 5 is 4. Button man, decimal. And 3 minus 3, you would put the 0 in front. So just think about this problem for a minute. So if Matt goes 0.46, he is going to be tied right here at the longest jump. It says, how much farther than his first jump must Matt jump to be in first place? If you tie at 4.02, is that still first place? The answer is yes. So even if he just went this much farther, meters, then he would be tied for first place. It doesn't say he has to beat that time. He just has to be in first place. So let's put it in a complete sentence. Matt must jump 0.46 meters farther. I'm going to say to be tied for first place, because that's telling that I know if he were to go 0.47 farther, then he would really be in first place. You know, like he would not tie. But Matt must jump 0.46 meters farther to be tied for first place. I'm going to put a smiley face on that because that was a very clever answer. Okay. We are only going to do one more. Which one do I want to have us practice? Number 16 is good. Patrick ran 53 meters away from Marty. Let's use our purple. 53 meters away from Marty. And then ran 16.02 meters directly back towards him. So he goes away from him, then comes back. So how far was Patrick from Marty then? Did he go 53 meters and more? No. He went 53 meters and then turned around and came back. So it's doing this. He went 53 meters, then he turns around and comes back. So they're kind of asking, where is he at now? So is this addition or subtraction? He went this far and came back. It is subtraction. If that's what you said, you were correct. So this is interesting. Which one do I put on top? 53 or 16.02? You put with how far he went first, which is 53. And I subtract 16.02. Whoa. Where is that all going to go? Well, which of these numbers in 53 is in the ones place? It's the 3. And which of these numbers is in the ones place? It's the 6. So the 6 has to go under the ones, and you have to keep everything the same, and that's where the decimal belongs. Remember, whole numbers have decimals at the end, right after the ones place. And you were doing subtraction again. So who has to fly in here? I love it. 0 the hero. We're going to be doing lots of borrowing and regrouping, friends. Here we go. You cannot do 0 minus 2, and you cannot borrow from that 0 until you borrow from this 3. And borrowing really is taking from it. Regrouping, borrowing from that, regrouping. 10 minus 2 is 8 in the hundredths place. 9 minus 0 is 9, and that's in the tenths place. Button man lines the decimals up. And then 2 minus 6, you can't do that. You need to go really slow and be paying attention. Borrow and regroup. 12 minus 6 is 6. And 4 minus 1 is 3. That's how far Patrick was from Marty at that point. What's the measurement? Meters. Okay. So how far is Patrick from Marty then? Patrick was 36.98 or 36 and 98 hundredths meters away from Marty. Okay, we are not going to do number 17 and 18. You do not have to worry about it, so hopefully you were paying attention and you didn't do the ones you had to do. All right. You need to find a pair of scissors and a glue stick because we are going to use the back of our journal to glue in what we just did. I'll catch you in the next video.